के ढेर में राई का दाना, रंग बिरंगा बैल सयाना।
हंस के ढेर में राई का दाना, रंग बिरंगा बैल सयाना।
तुझे पहर में टूटता तारा, पानी पे तिरता पत्ता पारा ना।
Hello, I am Diksha Paudel, Head of Social Media and Outreach of KU Hackfest 2022. Motivated by the impact KU Hackfest 2021 had on the tech enthusiast community, and with the motive to continue this momentous event, we are bringing you the second iteration of KU Hackfest, KU Hackfest 2022. For this year, we have partnered up with Major League Hacking, and we have Boost Games as Diamond Tire sponsor, GitHub and Solana as Gold Tire sponsor, Dayfolio, Polygon, Tech Himalaya, and Angel Swing as Silver Tire sponsors, Filecoin as Bronze Tire sponsor, and Tasket, Interview Cake, Exure, Digital Ocean, Replit, Clerky, Balsamic, and Eco3D as General Tire sponsors. I'd like to take this opportunity to thank our sponsors for this event could not have come this far without their support. Now, we are bringing you a session on Docker QuickStart and SmartBots learning. We have Mr. Kusal Ingham among us who will be joining us on the stage soon to conduct this informative session. Mr. Kusal Ingham is a programmer at Boost Games. He was also responsible for handling every aspect of the recently organized SmartBots coding challenge in collaboration with IOE Locus. The session will be 45 minutes long, and we expect everyone to learn something from this fruitful session. Without further ado, we'd like to welcome him on the stage for this session. Over to you, Kusal Ingham.
As a guest speaker here, so first and foremost, I'm sorry I changed the topic. So I didn't think that the quick start session would be informative, so rather than that, I changed it to a case study so that we can go through the overall step so that you can, let's say, you can find out about the pitfalls and why we actually chose Docker to run our tournament. So yeah, I'm Kusal Ingham. I work as a programmer at Boost Games, and I'll be giving a case story on how we use Docker for our SmartBots 2022 tournament. So I'll start with what SmartBots Challenge is about. So the SmartBots Challenge, in the SmartBots Challenge, we wanted, let's say, to bring a competitive aspect to programming in Nepal. So we don't have many, let's say, events like this where people can actually compete with each other. So to actually implement good algorithms so that they can learn themselves and also maybe grow in the process. So what we wanted to do was bring together people from the tech industry and students so that they could implement some kind of algorithm so that, and then also make them compete against each other for the tournament. So we chose Callback as the game because, well, we have a Callback game as well. So in case you are not familiar with it, Callback is a 4-person card game where each person is dealt 13 cards, and then based on the rules of the game, they try to win the game. So our tournament was based on Callback. So each team, let's say, they created a Callback bot, and then they competed against each other and our bots initially as well. And then over the period of 3 months, we had quite a great experience, and our winners were selected as well in the finale. So that's about SmartBots. So yeah. So one of the core part of our tournament was we wanted people as in students or from the tech sector, people who are working in the tech sector to be able to implement any algorithm, any let's say I wanted to create a bot using a deep neural network. So we wanted to allow people to do whatever they wanted. Let's say some people said they wanted to create a bot in OpenAI's gym. So we wanted to allow that as well. So one of our core, let's say, principle of our tournament was that participants should be able to use any programming language, any framework, any libraries, anything that they might be familiar with, and then they should be able to compete using that technology. So we wanted people to bring their best selves, their best skill sets to our tournament, so that, let's say, if their bot was truly great, they would actually win using whatever they had implemented. So we didn't want it to be a limiting factor. So for our corporate bot, there were actually two modes that we chose to run. In the qualifier phase, we use 2 versus 2 mode, where we use 2 bots from participants and 2 of ours, and then we we entered 4 of those bots in a single game. So Cortex is a 4-person game, so 2v2 for the qualifier phase, and then after the qualifier phase, it was a 4-team model where the participants themselves would compete against each other. So in every card game, there is an element of randomness. So you really can't figure out the performance of a bot just by running a single game. So you need to actually, let's say, run actually many games so that you can find conclusively whether a bot is actually better than another bot or not. So we thought about this a lot, and then just we picked a number and we chose to run 1,000 games, just because it sounds kind of right, and maybe it's enough. Actually, it was enough for the qualifier phase. So 1,000 games kind of sounds, it should it should finish in quite a so it should finish quite fast. We actually thought, but 1,000 is a lot of games, because to implement a bot, you actually need to, for the bot to actually take good decisions, it needs time. It may actually go through a search tree, or it may run through a neural network, or any of those, but each of those takes some time. So we wanted to allocate enough time for each bot so that it could play quite well. So we allocated 7.5 seconds to a single bot for each game, and then since we wanted to run 1,000 games, and there were 4 bots, 7.5 seconds. That came to a lot of hours. So running a single ranking, and if it took 8 hours, it's not actually possible, since there will be multiple teams who will be submitting their code and then running the ranking. So we wanted to make this a little bit faster. So one way we could do this is we could actually spawn multiple processes, each so that we could run multiple games in parallel, so that it ran faster. Each individual ranking ran faster. So we chose to run 8 processes on our bare metal with 8 virtual processors. So the worst case dropped quite significantly. It came to about, let's say, 1 hour, but bots usually do not take all of their allocated time, so the runtime is actually lower than 30 minutes. So one of the core things that is not, so how do I actually run the code? So let's say I'm a participant, and then I want to submit my own bot for the tournament. So how would I actually give my code to the server? So that was one of the, let's say, hard aspects of the tournament, because we wanted technology to not be a limiting factor, and yet we wanted them to use whatever tools they are familiar with, or whatever skill set they might want to bring to the tournament. So, and also another artifact was that we run 8 of the code in parallel, so it needs to be, let's say, each code should be segregated from each other so that they do not interfere with each other in any way. So how do we do this? So for this purpose, we actually chose Docker. So yeah, so one of the main reasons of using Docker is that it actually starts a VM-like instance where the code actually runs in an isolated environment, so that if you run, let's say, 4 of the same Docker image, none of them will actually, let's say, they won't have side effects. So that if I'm reading from the disk and then the another process is also reading from disk, both of this reading from the same file will not lead to something like race condition and stuff. So one of the reasons was that we wanted each pod to run in an isolated manner from each other, so that it doesn't impact their own, it doesn't, let's say, step on their own foot and then on the foot of others as well. So we selected Docker as a means for the participants to submit their bot. So to facilitate this, we actually provided them a QuickStarter code for on Node and then Python, and then steps on how to build it, how to run it, and then how to build, test, build, run, test, and then submit it on our dashboard. So the initial code was actually, it was runnable so that they could actually test, build the Docker image and then test it on our sandbox. So the sandbox run on the browser as well. So they could actually take that code, tweak it, and then run it on the browser. And then after they were satisfied with it, actually submit it to the server. And then we would take that Docker image and then start multiple containers from it, and then each Docker container would be entered into a single game at a time, so that we could run many games in parallel. So one of the, let's say, confusing aspect in the start was how do you actually run Docker from our code. So we actually use Node as our backend. So we wanted, let's say, how do you actually run the Docker from the code. So that was a bit tricky part for us, because there are multiple packages that you could use to manage Docker. So for our purpose, we actually choose to write a light wrapper and then run Docker through it. So I have got a short snippet on how we actually did it. So basically, it takes a few things as argument: the container, the port, and then the image. You can start any container. Let's start with what an image is. So when you actually build a Docker project or anything, you get an image from it. So you use that image to run a container, and then the container is, it depends on the image, but it is actually an isolated running environment. So this code takes the image ID, and then it takes the container ID. You can actually specify it, or Docker will actually assign a random container ID for you. So it takes the image ID, container ID, and then the port with the, what is this? The port to map the outside of the Docker with the inside. I don't think this makes sense, but it is actually for port mapping, because you cannot run the same container on multiple ports and then have them working all together. So the port needs to be unique. So we wrote, so this small snippet just starts the container and then runs it. So Node provides an execute command which runs the command on the cell, and then it provides access to the standard input, output, and error, and also the error status if it errors. So we wrote a light wrapper around it, and then we use this to actually run the Docker. So So another thing that should be considered, or rather, how you could actually use Docker for yourself. So one of the we actually do not use Docker in our day-to-day development because there's no need for us right now. But instances, but you could use Docker to use multiple versions of the same software on your machines. So this is a possible use case for Docker. Let's say you have got some legacy code and then it depends on an older version of the database that you are using, that you have installed on the system. So in cases like this, you can actually install the older version of the software on the Docker, and then you can start that Docker image and then use it with your legacy code. So that's one way to use Docker. And then another way is to actually separate your development environment from each other, since some packages are installed globally, which may actually lead to, let's say, consequences down the line when you have to run and build multiple projects. So it might be useful in cases like that. So you might want to consider using Docker there, or maybe you can use it on your deployment environment to manage different processes, different servers, different, I don't know, microservices maybe. So this is how you may actually use Docker in the day-to-day, let's say, development activity. So the downside of Docker is that it actually requires more RAM, so that it's actually quite expensive to run. Docker itself takes around 1.5 to 2.5 gigs of RAM, so your node server might actually take less than 100 MB of RAM. So it might not be worth it to actually run a single node server with 100 MB. You actually need extra 2 gigabytes of RAM, so it might not be worth it in most cases. So another thing to consider is that starting Docker containers will take some time. So it depends on how many library you have used, how many packages it has to load on runtime and stuff like that. But it is non-trivial, let's say. It will take at least a few seconds to start up, and then if you have got a lot of packages, well, it might take a long time. And if you're actually switching servers during that time, it might lead to, let's say, loss of requests, maybe. So these are the downsides that I can think of right now. So actually, this is it. Thank you.
Thank you, Mr. Kusal, for this wonderful session. Now we'd like to ask our participants to continue their hacking. All the very best, and stay tuned for more sessions that we will be having soon, including Angel Swing's drone mapping technology and why so few women in engineering. Thank you. Happy coding.
Thank you very much.